Hey folks, welcome back for another episode of Code Club. If we haven't met in the past, I am Pat Schloss, and I love going through live streams with you all, recreating data visualizations that I find in journals like Nature and Nature Microbiology, talking about what makes them work or what perhaps doesn't make them work, and then taking those critiques and then modifying the visual to hopefully make them easier to interpret, more compelling, perhaps a little less deceiving, if that's the way to think about data visualization. Sometimes they can deceive. So the task for today is to take a look at this data visualization. Yesterday, I posted a critique on YouTube talking about what I liked about it, what I didn't like about it, what I would do differently. And so what I want to do in today's episode is go back, recreate this, and then try to incorporate some of those ideas into this data visualization. If you are new to the channel, then I would love to have you, subscribe, like, do all those great things. As always, please feel free to use the chat and tell us where you are joining from. And yeah, just get to know everybody a little bit better. One of the things I love about these live streams is that they are fairly communal. And so I forgot to pull up a link to share with you all to the critique video that I posted the other day. So let me go ahead and grab that, and hopefully that's not too disruptive, but I'll paste in the link so that you can watch that later. Don't watch it now. Hang out with us and watch this now. So the visual that we're going to talk about is this one here. And I thought I had it open, but I guess I didn't. And let's see. Sorry, I should have been a little bit better prepared for this. And let me get this going. All right, there we go. And so here is the link that I will paste into the chat for you all. And normally I do these live streams on Wednesday mornings, but I have a conflict tomorrow morning, and so I'm doing it today on Tuesday. I suspect we'll have some of the same people that show up on Wednesdays, but perhaps we'll have some new people as well. And so I'm already seeing, I don't know if Professor Greg Tucker Kellogg is still on, but I think he was in Singapore and commenting that it was 2 a.m. in the morning. Mike P. is always here on Wednesdays from the UK. John from Barrington, Illinois, welcome. Joje from Sweden, welcome as well. And so, like I said, the visual that we are going to be working on came from a paper published in Nature Microbiology. It's published March 19th, just about 2 weeks ago, and it was titled Weaning Drives Microbiome-Mediated Epigenetic Regulation to Shape Immune Memory in Mice. And so they're looking at the effects of weaning on the microbiome and what effect that had on methylation and epigenetics in the murine genome. So I don't care about the science, right? I want to focus on the visual. And again, the visual that we're going to be looking at is in figure 4. And this paper suffered from a number of the same problem across multiple figures and panels, right? And so the main challenge that you can see in panel C and B here really is that they want you to compare under this low dose penicillin, that's what LDP is, what's happening to the gram-positives and what's happening to the other populations of bacteria, right? And to do that, you have to do a lot of work as the audience member, right? They want me to compare these two bars at 2 weeks without LDP to these two bars here, right? And then kind of transferring back and forth, looking at different populations. And similarly up here, they're looking at richness of these communities at different sequencing depths, with and without low-dose penicillin at different ages, right? And so there's just a lot going on that they're expecting the audience to do, to integrate and to do an analysis to figure it out. So my goal is to finish today in about 2 hours, maybe less, with something that is far easier to interpret, while at the same time going through recreating this plot. There's at least one cool thing in this plot that I'm really intrigued to try out with you, and that is this legend. Regardless of what you think about stacked bar plots, I'm not in general a fan of stacked bar charts. One thing I think is kind of cool is this legend. And that, again, in the paper, they're calling your attention to gram-positives and gram-negative bacteria. And so it's cool that they have kind of section headings in a legend. And I have never done that in R before. And so I've been doing some thinking about how we might incorporate that. And so that's what I want to, one of the things I want to do with you. And one of the reasons I think it's useful to recreate this visual, even though I might not be a big fan of the visual, right? So that's where we're going to go. If you have questions or comments along the way, feel free to holler. I also see that Brian from Iowa is here, and we have Robert from Oakland, California. Awesome. So I will fire up our studio here, and let's let me kill that. And the source data down here, there's a link at the bottom of this page. One of the nice things that a lot of Nature papers have that are open access, and I think even some non-open access papers, is a link for source data. And so again, we're looking at figure 4. And so this hyperlink downloads an Excel workbook. I'm going to go ahead and copy the link address here. And I've already got a R script fired up. I'll go ahead and load the tidyverse and read Excel. And I'll do URL and plop in that string. It's rather long. And then we can do read Excel URL. Actually, I need to download it first. I'm getting a little bit ahead of myself. It would be nice if I could read directly from a URL like you could with like a CSV, but you can't do that with Excel workbooks. So we need to download it. So we'll do download file, and we'll do URL, and then I will do figure 4.xls. I think it's an X. No, just XLS. Okay. And so if I look in my window over here, the files, you'll see that that figure 4XLS is there. And so now what I can do is go ahead and plop that into my read Excel. And that generates a bit of a mess. So most likely this figure 4XLS workbook is a mixture of a bunch of other stuff. It's got a number of tabs perhaps. And so we need to open this up and figure out where the data is and how it's formatted. I'm already noticing that the data are probably a little gnarly. It's always a good idea when you have a workbook to start in A1 as your cell, not in B3. That's just kind of silly. Just reminding myself that we are interested in panel C, okay? And so that's going to be down here, figure 4C. Let me go ahead and get that page in R. And so we can go ahead and do this. So sheet equals figure 4C. And so now what we see is that we've got that data. But again, they didn't start in A1, which is kind of annoying. And so let me see, zoom in here. So they're starting in B2. Really the data more or less starts in like C5, and the data is not tidy, right? It's wide. They've got two categories: without low-dose penicillin, LDP, and then with low-dose penicillin. And then they have 2 weeks, 4 weeks, 6, 8, 10, and 12 weeks with different numbers of replicates. And actually, we are interested in this first column, column B, for the phylum. And so what I think I'm going to do is go ahead and create my own column names. And so we'll create a vector of column names. And so let's go ahead and I will copy this set of cells. And maybe in here, I'll do column names. C, create that vector. I'm going to have to do some modifications here to the text, and I'm trying to think of the easiest way to do this. You know what? Yeah, let's go ahead and just wrap everything in quotes. And this can be a bit tedious, I know, so just bear with me. I was thinking maybe we could do this programmatically, but oh, let's do it programmatically because this is painful. All right, so to do it programmatically, what I'm saying is that we've got 2, 4, 6, 8, 10, 12, and there's 2 replicates for each week except for week 8 where there are 3. So we could do C, and then we could do what? So 2 week, 4 week, 6 week, 8 week, and 10 week, and then 12 week, right? All right, and then, you know, ultimately, I think this is going to be harder than it's worth because it would be easy. I could do like rep on this, each equals 2, and then that would get me column names with each of those being duplicated that many times. But you know what? Maybe we could try to do some, I've got another idea. All right, let's do this. Let's do Tibble, and we'll do week equals this. Actually, that should be, yeah, week equals that. And then we'll do reps equals 2, 2, 2, 3, 2, and 2. And so then that gets us column names, which is that. And so then I can do mutate, and I'll say expand equals rep week reps. And it's not happy about that because I'm giving it the whole column of weeks and the whole column of reps. And I'm already regretting this. I should have just copied and pasted, but we'll get there. And yeah, let's see. I'll go ahead and do a map. So a map, you know what? I'm digging a grave for myself here, and I'm going to just go ahead and copy and paste. Sorry about that. I should have just done that from the get-go. And maybe what I'll do is I'll just copy and paste this first set of column names, and we'll get those in quotes, these in quotes, these in quotes, and I'm gonna have to go back and put in my commas, I know. All right, bear with me. This is kind of the not so fun part of data visualization that's important, but not very fun. All right, and this is where it comes in handy to be kind of facile with your keyboard and shortcuts like copy and paste. But like I said, yeah, see, this is easy enough. I should have just stuck with this the first time through, and we're all right. Cool. So we've got those column names, and I'm going to go ahead and for now and comment that out so I can just work with the column names, right? And so this gives me the column names, and I think I will go ahead and bring in the glue package. So we'll do library glue, and let's go ahead and we can do let's call these rep names on that, and then we can do glue, and we'll do, let's see, all right, let me take a step back. Okay, what I want to do is I want to duplicate each of these twice, and for the first set I want to indicate that these are without LDP and the second is with LDP, right? So maybe what I can do is paste, or let's rep this twice, right? And so now I've got, yep, those, I think I missed something. And I think what I want to say is something like, all right, I'm already off to a rough start here. What's going on? So this is 12-week 1, and I think what I wanted was 12-week 2. Okay, all right. 12-week 2. Okay, now we've got that set duplicated twice. And what we could also have would be rep, and then we can do without LDP, and let's make that into a vector, and then with LDP. And then we can do each equals 12. And so then we've got 12 without LDPs, 12 with LDPs. And then I think we should be able to like paste on that with this. And let's see what happens. And I think I need an extra closing parenthesis. So we get that. And so the first 12 are without LDP, and the next are with, although it looks like I'm missing something. I don't know why I said 12. Let's see how long this is. Maybe it's 20. So it's 26. So each would be 13. All right, there we go. And so now we have the first 13 as being without LDP, the next 13 being with LDP, and finally, after all that, we have our column names. I think things will go smoother from here. Sorry. Sometimes it takes me a little bit to get going. All right. And so multi-cursor should be convenient for column names. You know, I have never figured out how to use multi-cursor. That is like one of those superhero strengths that I need, I think, to develop. Thanks for the encouragement to learn that. And I see we also have Fabian from Germany. So the question I see is, couldn't you load it in with read XLSX and range? So maybe I got a little ahead of myself. So let's go ahead in here and do range equals. I'm going to do range for sure, but we could do like B4. So remember that for me. B4 to AB15. So I guess it's not a vector. So B4 AB15, just double checking, AB15, right? And so we read that in, and we get these kind of funky column names, right? Because some of these are going to get duplicated. Well, they all get duplicated twice except for phylum, right? So I think what I'd rather do is start at B5. And so then that skips out any column names, but I need to put those in then, right? So now I can do call names equals column names, right? And so now when I run this, it's complaining sheet 2 has 27 columns, but call names has length 26. And that is because I didn't include phylum. So I'm going to come in here and I'm going to do C phylum call names. I think I could probably append phylum back up here, but let's do it here. And so now the error message goes away, and I see that I've got my phylum and I've got all these names. Okay, so we've got the data in finally. And the, again, as I mentioned, this is long format. And so one of the next things I'm going to want to do is to make it tidy, to make it long. And ultimately, I'm going to want to split apart the data on basically this first part, the 2-week hyphen, and then the replicate, or the number of weeks and the replicate, as well as the treatment group, right? And I was thinking about putting in a fancy delimiter here, but I think a space is fancy enough. So let's go ahead and do pivot longer, and we'll do minus phylum. And yeah, that's probably good. And so now what we get, if I could do this, is we've got our name and our value. And then what we could do is, it used to be separate, but they've changed it. So I think it's separate delim or wider delim. That's what it is now. It used to just be separate. And so here, what we're going to separate will be the name column, and then our delim, not delip, it's going to be a space, and our names will be week and treatment. And so now we run that, and now we've got a week column and a treatment column, right? Winning. All right. So, cool. All right. So we now have our phylum, our week, our treatment, and our value, which I think puts us into pretty good shape here. And let's go ahead and see if we can make a plot, right? ggplot, AES. So on the x-axis, they had the week. On the y was the value. And then the fill, the color, was the phylum. And that's good. And then we'll do plus geom col. And then we also need to do a facet wrap tilde on the treatment, right? Because they had one facet without low dose penicillin and one with. So we'll go ahead and run that. And I already have this for figure 4C set up to save in the right dimensions of what I had previously. And, oh, I thought I had this set up. All right. And so this is what I get, right? So this is my version. This is their version. We have a ways to go, right? And so, so you can see, I mean, with a little bit of fumbling on my part to get those column names right, we got there reasonably quickly, right, to getting a plot. And so something that I kind of notice is that there are names in here, like ascomycota, that are not over here, okay? And so let's pay some attention to that first. I'm kind of feeling like the order of the weeks is also a little bit out of order. These big purple bars are probably like the Pseudomonodota, which I think is like this green, right? So those big green wedges, and they seem to be embedded. So we'll have to do some work with factors here to get things going. We've got with LDP on the left, without on the right. We'd want to flip that, right? So let's start by looking at the phyla names. And because ultimately what I'm going to do is I'm going to probably do something like grab these names, make a vector out of it, and say, is my phylum in this list of phyla names? So let's go ahead and remove that P with the underscores. And we'll come back to ggplot here in a minute. And yeah, so we'll go ahead and we'll do mutate phylum equals, and then we'll do str remove on phylum. And the part we're going to remove is the P underscore underscore. I think that's 2 underscores. And so now what you can see is in that first column, we've got the Pseudomonodota, right? And then if we pipe this back into ggplot, we now have removed those P underscores. That P underscore is, I think, coming out of green genes and their convention for indicating that that's a phylum level, right? So again, I want to think about like, what are these names? And there's so many names here that they don't all fit onto one screen. And ultimately, that's another critique that I have of stacked bar plots, is that you get to a point where you have just like too many colors, right? Like we have this color gradient where it's hard to see anything. And the thing I pointed out about theirs is that they have 2 reds that are very similar to each other. And actually, they really call attention to the Bacteroidota as being important, something they really want to highlight. But at first glance, you might not know if this is the Bacteroidota or the Spirochaeota, right? And so that's again because there's only so many colors and only so many differences in color that you can achieve. So let's come in here and we'll do a count on phylum. And we see that there are actually 11 different phyla here, or 10 plus others. Whereas over here, they had 2, 3, 4, 5, 6, 7, 8, 9 phyla. So there's a couple in here that they got rid of. And I'm not really sure which ones those are. So I'm going to go ahead and highlight these. And we'll come over and let's make a vector of phyla names, and we'll have this. And again, we'll go ahead and get this all cleaned up. And I need to make this as part of a C function. All right, and I don't need that gram bacteria. Get these all quoted. All right, and then we can clean this up. Almost there. All right, so now we've got our phyla names, and what I could do is I can do a filter looking for where phylum is in phyla names, okay? And so this is going to look at the values that I had in phylum, which are these names here in this first column of the count, and say, are these names in this listing? And if they're not, then they're going to get dropped out, right? And so we can go ahead and pipe this into ggplot. And so now what we see is perhaps fewer colors here. And the other thing I notice, and maybe you notice too, is up at the top, they don't add up to 100. They don't up to 1, right? And so that's because I removed things that were no doubt rare. So I think those rare things need to get pooled in with other, okay? So it's not going to be as simple as filtering those out. I should have thought of that, right? So maybe what we could do is we can take this logic though, and we can add that to the mutate. And what we'll do is phylum equals if else. So if this is not true, right? Or we can do it this way. So if this is true, then the phylum is going to be the phylum. Otherwise, if it's false, so if phylum is not in phyla names, then I'm going to call this other. Okay, and I think that's what they called it. Well, they actually don't have a column for other, I'm noticing, right? Yeah, it's interesting. They don't have an other category. That's weird. All right, well, I'm going to call it other. And then let's see where that gets us. So then we'll have this phylum where there's going to be multiple others for the same week and treatment. And so what I'd like to do then is a summarize on value equals sum on value. And we're going to do a grouping by, and we'll do phylum, week, and treatment, okay? And so what this is going to do is within the same phylum, within the week and the same treatment, it's going to add up the values that have those same values. So for like Tsunomoto Dota, there's only one value, one version of that phylum, one line of that phylum for that week and that treatment. So, you know, for this, nothing's going to change, but for other, it will, right? So if I were to come in here, do filter phylum equals other, then we're going to see here potentially some duplicates, but yeah, I just want to double check that it's called other. If I do like count on phylum, there's my other, and you can see actually, yeah, that we've got other at 52 rows. So there's duplicates in here, okay? And yeah. And maybe we could see that if we did like arrange week, right? Yeah, and so here we see like this, oh, let's do week and treatment. Okay, now what we see is that we have basically the same line duplicated. So what we're going to do in the summarize line is basically add those two values together. Okay, so if I go ahead and grab that and put that down after the summarize, now what I see is that 0.107, which is the summation of these two values here. Okay, so that's what I'm doing. All right, so now if we run this and regenerate the plot, I've got that back here. We now have a limited number of colors. There's so much going on here, it's really hard to see. And so I think what I'll do is start with theme and do legend.key.size. And let's do unit 10 pt. And there we go. That shrinks that down a fair amount. Okay. Great. So, so now we can see that we've got those 9 phyla plus other included here, right? And we can also see kind of where we went down this path here that the top edge is flush with 1, right? Cool. All right. So maybe what we could do is let's go ahead and bring in the color that they used. And yeah, so to do that, we'll do scale, fill manual. And I'm going to go ahead and do breaks and, or let's do values, right? And so we can then have these like named values. And let's see, I thought I had phyla names. So I've got these phyla names here. And maybe what I'll do is I'll go ahead and grab this vector and I'm going to paste it in here. And so what I can then do is I can then take the name and have it equal to the hex code for the color. So let's go ahead and do that. And I've got my digital color meter here. And so we can kind of pick those off here. So this Basiliota, plop that in. The Actinomyceota. If nothing else, this whole exercise helps me to practice pronouncing these crazy new names, which I wish someone would have asked me. Why would anyone ask me? All right, so we'll get these in here and get that cleaned up. And then we need the Spirochaeota, which is that reddish color. Right. And then the Ferre. Let me see if I can get these on one line. All right. I should also add that at the end of this, I will post the code that I'm writing to a blog post, and I'll include that link down below in the description to this video, okay? And I'm forgetting, okay, de Ferre. This light green color. Yeah, so see, like, there's a number of colors in here, like these two that, I mean, when they're right next to each other, it's easy, so to speak, to see the difference. But when they're in the plot, it's a lot harder, right? And so here's that other one, the Bacteroidota. Yeah. And then the Campylobacteriota. All right. And the Chlamydiota. Boom. And then finally, this one. Plop that in. All right. So then this should get us colors that match the original. Right? So I'm going to go ahead and shrink this down a little bit so it's not using the whole screen. Okay. So mine's on the top, theirs on the bottom, and it's the same aspect ratio, more or less, right? Cool, so we've got the same colors. Let's go ahead and get things in the same order. And one of the critiques I had was that I think putting it in the same order is probably not a good idea, but whatever. Let's go ahead and we can make that a factor, right? So we've got these phyla names that are in the order that they had them in the plot. And so to do that, we can come back here and we can do mutate phylum equals factor on phylum, and levels equals, and I call them phylum names, right? And so then we add that all in, and it's unhappy because I think I put a plus sign at the end of a mutate, but I meant a pipe. All right, there we go. So we've got things in the same order. I have NA here, and so I should probably put other in. So let's go ahead and put other here. And then down in scale fill manual, I could then do other. And then let's make that like dark gray, like so. And there we go. We've got our other category, which they didn't have. And maybe we could get rid of that before it's all said and done. But let's roll with this for now. Let's go ahead and get rid of this title for the legend. We can do that in scale fill manual. I often do it in these live streams with the labs function, but I can do name equals null. And we see that that gets rid of that, right? So there we go. And cool. Now let's change the ordering of our two facets to put the without on the left and the with on the right. Again, that's going to be a factor, okay? And so I have a factor statement here. So maybe this mutate here on 26 and 27 will become where I'm using factor to reorder things. So we'll do treatment equals factor on treatment. I'm going to do levels equals, and then I'll do WO LDP and then W LDP. So we should get without on the left, with on the right. Yay. Go team. We got that. Cool. We could also think about like changing these labels. We can do that back in this factor as well. And so maybe I'll do that here briefly. We'll do labels equals without low dose penicillin, and then we could also have with low dose penicillin. And so that gets kind of blown out. Maybe we could put a line break in those. I like to spell out the acronyms. I don't really like having a ton of jargon in the figures because I'd like for figures to kind of stand on their own. And so if you've got jargon in there like LDP, you might be wondering like, what's LDP? So we'll mess with the font here in a bit and trying to shrink things down so that we can kind of match the sizes. And yeah, we're gaining on it. We're gaining on it. While we're talking about like things like labels and such, why don't we go ahead and play with the labels? And I'll come in here and I'll do labs x equals null because it's obvious that these are the weeks, and actually they have age, and they also are duplicating WK, right? So I would prefer to drop the WK and do like age parentheses WK or something like that, or week. But let's go ahead and get this as our Y. And it breaks at relative abundance. Oh, and I think I forgot a plus at the end here. There we go. So we've got that title. We got rid of the x-axis. And now what we need to do is think about the x-axis, okay? So recall that I'm mapping week to the x-axis, and I'm forgetting what that looks like. So week is this 2 week dash 2 dash 3, so forth. And so what they have is just like the 2WK. Okay. Right. Let's see, what would be the best way of dealing with that? Well, recall that I had all this for the week. And I could imagine having like a week and or a week rep and week. So maybe that's what I'll do here. I will pull out this C vector and make this week rep. And then I'll make this week rep. And I think nothing should change at this point. Famous last words. Okay, nothing's changed. And so again, I pulled that out, that week rep, and let's do like week label. And I'll then do str remove on week rep, and we'll remove the hyphen and then basically anything that follows the hyphen. So then our week label should just be those week labels, okay? Cool. And so now if we come down, I can add a scale x discrete. I can do breaks equals week rep, labels equals week label. Get a plus sign here. And I can see like the last character here is a K rather than like a hyphen 2 or 3. And so I know it's there, but you'll notice that theirs is angled. And so I'm not a fan of angling these things like they have, but let's do it the way they did it for now. And we'll do axis.text.x equals element text angle equals 90. And there we go. But they've got this like weird justification, right? So I can tell that the 10 week is first and like the 8 week is last. And that's because they're coming in here alphabetically. And I feel like it's kind of like bottom justified or right justified. So let's go in here and do like hjust equals 0.5. That didn't do it. Is it vjust? Yeah, so it was vjust because sometimes it's confusing because, you know, is it bottom justified or top justified? I think by default it might be bottom justified. And then when we turn it 90 degrees, it effectively looks right justified, but it's still really bottom justified. It's just been turned 90 degrees, right? And so by then doing vjust equals 0.5, we then get it to line up. So that's a win. Let's go ahead and we can shrink the size while we're here. Let's do size equals 7. And I think it's all like smashing together also because these names are so gigantic. So let's go ahead and shrink our legend text. And we'll do unit or element text. Size equals 8. And then let's also change the key size. Maybe we can make that 7. And so that shrinks that down and shrinks the font too. And I feel like, well, we have a different font. I feel like those names are pretty similar. All right. And this legend is separated a bit from the plot. So we'll worry about that later. Right now, let's think about the ordering of the weeks. And I can see already that they're not in the right order. They're going alphabetically. And that's again because by default, a factor is treated alphabetically. It's set the order is alphabetical. And so again, on X, we have week. And let's make week a factor. So we'll do week, factor, week. And we'll do levels equals. And then what I had back up here was week rep. And so we'll put that in. And so now we can see that we've got 2 and that we go out to 12. Okay. And so we are, I think we're center justifying, but we'd rather have it be right justified, right? So you can see down here, like all those WKs line up. So let's do HJust equals 1. And so those all line up there then. Yes, the line break in the thermode is sulfobacteriota. Yeah. If we entered that, then things would probably clean up a bit. So let's go ahead and do that. And let's see. Let's go ahead and we can set that in phylum, right? Where we did levels, and we can also do like labels. And I'm somewhat tempted to copy this down and do that. And let's clean this up. I'm sure there was an easier way to have done this, but this is okay. And so the line break is after the sulfo. All right, and then we've got this other, okay. And I just lost it. And that's because I need a line break down here in the scale fill manual. And that is pretty nasty. I think I know how to fix that. So we had legend key size, so I think this should be legend key height. Oh. No. That's also bad. I'm gonna, let's see. That's really weird. Height and width. Yeah, so that's odd that it's like forcing it over 2 lines. I think for now, I'm going to, let's just leave that there for now. We can see this, the 2 weeks and whatnot here. Okay. We can also now see most of the title. Our y-axis labels too big. So let's go ahead and change that. So we'll do axis.title.y equals element text. And we'll do size equals, let's do 8. Okay, so that's, I think, pretty good. All right. Let's see. So yeah, the suggestion from yeah, let me see. James is suggesting GG text with element markdown. Yeah, if you used element markdown, then you would use the anchors with a BR in the middle. All right, so let's see what to do next. I think I could probably shrink the font down a little bit in that text. Let's go down to 7. So that now is about the same size as what they have. And let me know what you think of these titles. I think the strip text is too large. So we'll do strip.text element text. Let's do size equals 9. Oh, I guess they were already 9. So that shrinks that down a little bit. Okay. so the text here on the y-axis is quite large. So we could also do axis.text.y equals element text. One of the things I like to do in the theme function is to try to keep things that hierarchically are similar to each other together, right? So I've got like this axis text x, so I'll put axis text y below it, right? And then I'll put the legend stuff together, I'll put the strip stuff together, right? Let's do size equals 7. And you know, like on some of these, I think we could probably go down to like 6, but I don't want the font to be so small that it's impossible to see, right? Like I see why they abbreviated WLDP and LDP, because that fits nicely on like a single line. So yeah. One thing I didn't like is like this relative abundance. For whatever reason, I prefer to have relative abundance as a percent. Because sometimes we get like relative abundances that are quite small, and I'm like never quite sure, is it a fraction or a percent? So I'd prefer to be explicit about that. So what I'm going to do is I'm going to come back and I'm going to do at phylum level and then put a percent sign. And so then to do that, when I do my value, y equals value, I'm going to go ahead and here and do 100. And you'll see that that also made those numbers smaller because I don't have all the significant digits off to the right. The other thing that you'll notice with mine is that 0 is right at the bottom, whereas theirs, 0 is floating above the bottom, which I thought was weird. Also, there is a way to get the y-axis text on both panels, but I don't think that's necessary, right? I'll also point out that one of the critiques I had in the original was that if you look at this bottom edge of theirs, it's actually higher than the bottom edge on the left side, right? So this is not a lot, but it's higher, right? Whereas by using facets like we did here in R, you know, I can draw a line straight across and you'll see that's like right at the floor, right? And the same for the top. So I think that's a benefit of using those strips. One thing that I think is important on a bar plot is to not have them floating. And so I'd like to get rid of this bottom, and also let's get rid of all the tick marks. And so let's do the tick marks first. So we'll do axis.ticks equals element blank. And so that, I think, removes a lot of the heaviness from the plot. And so then let's go ahead and get rid of the expansion. Before I do that, I'm going to turn off the gray background and the grid lines. One other thing I notice over in the legend is that with this default of theme gray, it's got a gray background to the legend. So let's go in here and at the top, let's do like panel dot grid equals element blank. And so we can see that gets rid of all the grid lines up here. We could also do panel dot background equals element blank. So then we've got a white background, and then you'll notice also over here on the legend that we no longer have those background colors. Yeah, the I think the y-axis text is a little big. Y-axis title, sorry. If that came down to 7, and we could probably do the same size for those strips to make those 7. Okay, and let's get rid of that expansion, right? Because we have, I mean, if I brought back in the panel background, right, we've got the gray at the bottom and the top. And so to get rid of that, on here I could do scale y continuous, and I could do expand equals c 0, 0. And so that's going to turn off the expansion on the bottom and the top. And so now you can see that that blows out like that. Looks good. Of course, although you can kind of see it, can kind of see the gray. To get rid of that, of course, we'll remove this comment from the panel background. Okay, and so that makes that a white background. Looks good. And all right. So the strips have this gray background. Let's do strip dot background element blank. Actually, before I do that, I want to change the margin here. There's a lot of padding around it on the top and bottom that I don't think is necessary. Let's do margin equals margin. And on the bottom, I'm going to make it 2, but kind of remove the rest of the margin, right? So now when I turn off the background by bringing this in, I then get the white background, right? And so I noticed, however, so that's, yeah, I noticed, however, I lost the 100 up at the top. And so I think in scale Y continuous, I need to do limits equals C 0 to 100. And so that got me my 100 back. Okay, good. All right. The 2-week without LDP doesn't look the same as theirs. So thank you. You know what? I think I have them. Do I have them flipped? Yeah, that's interesting. So my colors are in a different order. So this is the original and this is mine. And why would that? Let's look at the data, right? So it appears that the 2-week without LDP let's see, 2-week without LDP, that blue is the bacillolota, which is this. So 2-week 2, 2-week 3 without LDP. I think that's on them, right? Because it goes 0.08 and 0.39, and those look to be about the same height. Whereas over here, these are like 0.11 and basically 0.11, right? I'm going to say that's on them and not on me. Yeah, so if you look at mine and look at their spreadsheet, the Bacillota, 0.08 and 0.39, 0.08, 0.39, right? I don't think it's in the summary. I think it's in the actual raw data that looks different. Yeah, that's weird. I don't know what to make of that. Maybe to make ours look a bit more like theirs, I'm not totally sure what it was that they used to order the bars. But we could maybe change the order a little bit where they go from like the bottom to the top. And again, this is theirs on the bottom. Let's see. So this is the ordering. And I'm going to put this on another monitor so I can look at it at the same time. But on the bottom, we're going to want the Bacteroidota. Oh, what a pain. That's an... Um, let's see. So these values will be the order. Okay, that's fine. So we'll go ahead and change the order. So the one on the bottom needs to be the Bacteroidota, followed by the Bacillota. And then above that is the green, which is the Pseudomonadota. Everything's like Dota now, which should be easier to say than it is. And then the dark blue, which is the Actinisemyota. And then it's like the pink Campylobacteriota. And from there, I'll just say, who cares, right? All right, and so then I need to update the labels in this. So it's going to be all this stuff here in the labels. And you know what? I'm gonna do pretty phyla, and I will then do str replace on phyla names, and I'm going to replace this with the \n. All right. So we'll do phyla name is pretty phyla, and then in labels we'll do pretty phyla. Okay, and that is the opposite of what I wanted. Oops. So how did that get flipped? Well, I think we can always come in to scale y continuous, or phyla names. I would think that the Bacteroidota, maybe it is the opposite. If we do like reverse on this, there we go. Now we have the red on the bottom, and we more or less have the order that they have and the appearance that they have. Again, as someone pointed out, we have this tall green bar. Okay. All right. And the legend is a bit out of whack in terms of order, which I thought my scale fill manual would have gotten that right, except I think the problem with doing a named vector like this is that we lose that order, right? And so let's see, if I do like that, if I do breaks, I should be able to insert like this and clean this up. Oh, I need a comma at the end of these lines. I heard you. All right. There we go. So now we've got basically the same plot, again, except for that 2 week. That's really interesting. I think that's on them. I don't think that's on me. Everything else looks pretty much the same. One other thing that I will do before I take on the legend, don't worry, we're going to get there. So Joe J says, I think you can reverse it in guides with fill equals guides, legend, reverse equals true. That's cool. Yes. So the spacing here is a little bit not desirable, right? So we can do like legend, I think box spacing. So this is the spacing between the plotting area and the legend box, and it takes unit. So let's do unit 10 pt. See where that gets us. So that moved it over a little bit. Let's just go to 0. And so that brings it over. Okay. I think the legend itself has a margin around it. Okay. And I think to match theirs, I think their text on the x-axis is a bit smaller. So if I did like axis text x6, that fits a little bit better. And then we would need age in the lower left. And maybe the y also should be 6. Just feel like that gets really small. I don't know. So to put the age in the lower left, don't worry, I'm not stalling, just a little. Let's do an annotate, okay? So I don't have to like scroll back and forth. I'm going to do a plus annotate, and I'm going to do geom equals text. And so I'm going to be plotting outside of the plotting window. And so what that means then is that I need to use chord Cartesian, and I need to put my limits inside chord Cartesian. So we'll do chord Cartesian. I'll do ylim equals c 0 to 100, and I can get rid of this. And I think I also need to do xlim, and we have 13 things across the x-axis, and I'm never quite sure. I think they're centered on 1, or maybe they're centered on a half. I don't know. But let's say like C 1 to 13, and let's see what that does. And we also in here want to do clip equals off, so that we can plot stuff outside of the plotting window. Let's see if this works. Is not happy. Size. Oh, it's probably because I have annotate in here. Let's turn that off. Okay. Okay, nothing changed. That's good. And so now what we can do is come in here with annotate, and we'll do x. So if that first bar is at 1, this here is probably 0. So let's do 0, and y equals, so if this was like 10%, let's do y equals -5. We'll do label equals age. And there we go. We have age. It's just big. And we have it on both panels. So let's only have it on one panel. So one of the cool new features within the latest version of ggplot is you can do layout equals 1 to say you want it on panel 1, or you could do 2 to have it on panel 2. So let's do 1. And so now we have it on 1. And so now let's go ahead and shrink that. We'll do size equals, I feel like that's like 6. So size, and then size.unit equals pt. So that gets us age. Need to capitalize Bacteroidota. I don't see that. All right. John, if you can like expand what you're just saying about capitalizing Bacteroidota, you can do that. Is it possible to control the line height where you have broken? Yes. Yes. Yeah, because that's a bigger gap than what we have there. Let me come back to that. Let me get this age in the right spot. So let's move it to the left and down a bit. And so to the left would be like -3, and down a bit would be like -8. Oh, that's too far. All right. Oh, right. It's probably like 1.2. All right, let's do 1.1. And again, mine's on the top, theirs on the bottom. And I think that looks pretty good. So the line height in the legend. Let's see. So again, all my legend stuff is here. I'm going to maybe make this 8 and 8. And that'll make my squares a little bit bigger to kind of match theirs. But still, like the spacing in this thermo is greater than it is between the phyla. And also that key height is really annoying. Not sure what to make of that. Let's see. So that was in legend text. Here we can do, within element text, we can do line height equals, let's say 0.9. So that didn't really do anything. Let's go let's do something crazy, like 0.5. And so that compresses it, right? And I'm noticing that like my sulfo backslash, I need a hyphen after the sulfo. And I need another one here. Okay. Oh, okay. I reran everything accidentally. Anyway, here we go. And I lost my thermo. Thermo desulfo backslash n. Okay, I need a hyphen here. Okay. Let's try this again. So that that was 0.5, I think. Let's try like 0.7. Something like that. Again, they didn't have the other, like I have other, and oh, sulfur, okay, backdrate, yeah, gotcha, okay. So this key height is really annoying to me. I don't know if I did like 4, that makes them all, that's like changing the height of the line for each key. But in this case where it goes over 2 lines, I don't really know what to do about that. Except to like not hyphenate the name. I don't really like the hyphenation of the name, to be honest. And I think what I'm going to do is go ahead and remove the hyphen. Hyphen backslash n. And replace all cases of that. Okay. So we get that. We also have quite a bit of margin around the plot. So let me go ahead and move this annotate up first. And plop that in there. Make sure this all still works. Okay, good. And then I was going to remove the legend. So if you do like plot.margin equals margin, then the default is 0 all the way around. And that should make it pretty tight. Something like that. And you know what? Like, my individual panels are still wider than their individual panels. Mainly because I got rid of this text in the middle. There is a margin around the legend, and there's a margin, I think, to the left of the text. So in legend text, let's do margin equals margin everything. And so that, you can see, brings it in real close. But let's make that like, let's do L equals 3. Maybe 2. Something like that. And then let's get rid of the margin around the legend. So we have like legend.margin equals margin. And if we do zeros all the way around as a starting spot, get something like that, right? And so let's get a little bit to the left. And so this is top, right, bottom, left. Let's do 3, like that. So I think that's pretty good. Maybe on the overall margin for the plot, we could do, let's do 1s, or let's do 2s all the way around. Okay, there we go. And I think even with spelling out the full name, my individual facets are wider than theirs. I don't know. I think that's cool. All right. So the legend, something that caught my eye when I first saw this plot, to be honest, was the legend. And that I liked the bacillota and the actinomycota being under gram-positive and the others being under gram-negative. So this got me thinking, like, well, how do I do that? And so I did a little bit of sleuthing and saw that I could use different aesthetics and then basically recreate the legends for those aesthetics. So let me show you maybe what I mean. So if I come in here to my ggplot, let's go ahead and do like alpha equals phylum. Okay, it's going to probably complain because it doesn't want to use alpha for a discrete variable. And so here I get 2 different sets of alpha. And what I'm going to do is, you can imagine that this top one, this top legend, I removed the name, but I could give it the name gram-positive, and I could give this one the name gram-negative, right? And so, and then by using breaks, like the breaks that I want to use, I can specify what things I want to show up in each of the legends, okay? So hang with me, we'll get this. So I'm going to come back up here to my scale fill manual, and here I'm going to say, instead of null, I'll say, what did they call it? They called it gram-positive bacteria. Okay, and then the breaks are really those first 2. And so now what you see is I've got gram-positive bacteria, and I have the bacillota and the actinomycota, right? Cool, huh? Okay, now what we want to do is in phylum, or in the alpha, we're going to create another scale. And so I'm going to do scale alpha manual, and I'm going to do name equals gram-negative bacteria. And then I'm going to wish that I hadn't deleted those other things. Let me undo some stuff here. I'm going to copy that instead of deleting it. All right. And then we'll have breaks equals this. And that goes there, and that goes there, and that. Okay. So insufficient values in manual scale, 10 needed, but only 0 provided. All right. So I think what I might be able to do is to say, can I say values equals 1? Nope. 10 needed. All right. Well, let's do, where are you? So we're going to do rep 1 10 times. So what I'm doing is I'm giving everything the same alpha, right? I'm making everything 1, which is opaque, which is what it is by default, right? And so there we go. We then have the gram-positive, the gram-negative bacteria, and then we have theoretically are gram-negative bacteria, right? But we don't have our color, right? And so what I need to do in probably my scale alpha manual is I need to use the guide argument. Let me see. Scale alpha manual, and let's see, it's in those triple dots. So let's see down here. Name, minor breaks, labels, guide. Okay, so the argument is guide. So we'll do guide legend, and then we're going to do override AES equals, and then this is going to be a list. And so what we'll then do is fill, and so we're going to override the fills. And so basically what I need are these colors, and that's these, right? Yep. So I'll plop that in here and assign that to a vector, and bing. All right, we got it. So again, I was nervous there that I couldn't remember how to do this. What I did to step back was that up in ggplot, so basically what I'm doing is I have two legends, right? It's instead of one legend with two parts, I've got two legends. I've got the phylum and I've got the alpha. And then the alpha, so the phylum, I've got all these colors, and I'm only showing the ones that I want to show, right? And so that's the same for scale fill manual as it is for scale alpha manual, right? Like down here, I have those breaks, right? And then the values for like scale fill manual, I'm actually going to use those values. But for alpha, to set the values for the fill, I'm giving the colors that I want, all right? And so then what we get is this, right? And let's go ahead and shrink the size of the title, if we could. And let's see, give me 5 minutes, and then we will go to showing a better way to do this, okay? So my brain is getting fried, but this is fun. All right, I want to shrink the size of those titles. Okay, so we will then do, so that's in legend here. So let's do legend dot title, and we'll then do element text. Let's do size equals 7. And so that shrinks that down. But again, there's like a big, I think, margin below the title. And so let's do like margin equals margin. Again, that's going to turn everything to 0. Oh, that was not happy. Okay, I misspelled margin. Margin. Oh, where'd you go? There we go. So again, that like really shrunk it down, right? So let's go ahead and add a little margin to the bottom. Let's do like 2. Like so, right? And we could shrink that spacing here. So let's do legend spacing Y. And we could then do unit. Let's do like 2 points. Okay, that's too close, I would say. So let's increase that to maybe 5. Bam. Okay. So, of course, there's positive and negatives are superscripted. Mine is not. So let's go ahead and make that superscripted. And so to do that, we'll do library ggtext, and we'll do legend title. Let's do element markdown. And so at this point, there's no markdown in there. So everything basically looks the same. And what we'll do then for our gram positive and gram negative in our titles is I'm going to add soup for superscript. And we'll do the same thing up here around the positive. And voila, we get the superscripted gram negative and gram positive. But oh, why can't anything be easy? It flipped the gram positive and the gram negative, right? And so my understanding is that the ordering of the legends is unpredictable and somewhat random. But there is a way to specify it. And so what we can do within guide is to say like order equals 2 for the gram negative. And then in scale fill manual, I can also do guide equals guide legend order equals 1. And I got to spell guide right probably. And so now we get gram positive at the top, gram negative on the bottom, right? So there we go. What do you think? There's still a lot about this plot that I do not like, right? Yeah, so there's a number of things in here I don't like. Like I don't like the duplicated WKs. I don't like that there isn't summarization of the data. I don't like that I have to look back and forth. But my goal was to recreate their version of the plot with some subtle tweaks. One thing I always forget is that with theme gray, the default color is gray. But if I came back up here and I did like text equals element text color equals black, I think that'll make, it's kind of hard to see the difference, but that makes all the text black, right? So there's a few little subtle changes that I made from theirs to mine, but I think on the whole, even with these subtle changes, I think mine's better, of course, but that really wasn't the point of recreating theirs. The point of recreating theirs is to figure out how to recreate theirs, right? And doing things that seem a little bit hard, like these legend sections, right? I think that's really cool. And I've already picked out the visual that I'm going to show you next week. And we're going to use the same hack again because I found another plot that uses, it's not the same idea, but it's the same idea. So think about this, wrestle with this, and see if you can't, think about how this is working, right? Okay, so now I want to improve upon this, okay? So, and again, if you want the code to do this legend hack, it will be at the blog site, at the blog post that I'll cite down below in the description for today's episode. All right, so we have half an hour, and what I would like to do is go ahead and take some of this, and I'm going to copy it down. So I'm going to grab maybe like all this stuff, the data processing. And you know what? I'm going to call this data. And then instead of piping it directly into ggplot, I'm going to do data, right? And so we've got this data object that we've saved and everything's good. All right. So I'm going to take this and then do redo. Okay. So we've got, oh, I didn't mean to copy that. Okay. So we've got data, right? And something like that. So what I would like to do is make it easier to compare the taxa that we are told are relevant, right? So we're told that like the gram positives were decreased on penicillin, and that the gram negatives bloomed with penicillin, right? That basically had more gram negatives and fewer gram positives on penicillin versus without penicillin, right? And so again, it's kind of hard to see that, and for a number of reasons, right? Like, so like you're asking me to visually average across the points, across the weeks. 8 weeks here, there's 3 replicates. Everywhere else, there's 2. I don't have a good way of looking at variation. We've got the whole stacking effect, where I'm not sure if this color is from the Bacteroidota or the Spirochaeota. It's hard to compare like this green, which is the Pseudomonads, across the two, right? Because they don't have a common baseline. Perhaps I'm interested in these Campylobacterota, and here it's hard to see what's going on too. And so what I'd like to do is replace this with 4, 5, maybe 6 panels. I think maybe 4, where we're going to look at the 4 most abundant phyla here, look at the relative abundances of them on average for each week over time. So if you show me time, I'm going to expect time, like age, to be on the x-axis, abundance on the y-axis. That's just so ingrained how we think about time series data that to do something different would be weird, right? And so maybe that's a constraint. I don't know. That's just the way it is. So what I'd like to do, and so then for each facet, we'll have time on the x-axis, abundance on the y-axis, and each facet then will be a different phylum of bacteria. And then for each of those facets, we'll have 2 lines. One line for with penicillin, one for without penicillin. And that way, for each of these phyla, I can compare the relative abundances with and without penicillin. Crystal clear, okay? So, to do that, we've got data, and we need to, what? Well, let's start by plotting some data. So let's do ggplot AES, and on the x-axis, like, I'd really like to have the week as a number, right? And so maybe before I even get to ggplot, I'll do a mutate week dbl, so week as a double. And so then I'll do str replace week as, and we're going to replace or str remove, sorry. And some of what I'm going to do here is because I already created data and I'm using it for the other plot and I'm going to use it here. So just kind of roll with that maybe, realizing that like we might use different steps if we were starting from scratch with the Excel workbook, okay? So we'll have str remove week, and then we'll remove the wk hyphen, and then the back d star. So back d matches a digit, 0 or more. I guess I could do 1 or more digits. And so now what you see is I've got this week double, and then I could pipe this to as.numeric to get that to be a double, right? And so we're going to pipe this then into ggplot, and I'm going to put on the x-axis the week dbl. On the y-axis, I'll put value, and then color, I'm going to make treatment, right? And okay, so we've got on our x-axis time, the y, the abundance, and then I'm going to do, let's do geom point for now. Probably do geom jitter eventually, but let's do geom point. And then we'll do facet wrap tilde phylum, right? And we'll do n, well, let's just leave it there and let's see what we get. And I need to then open up my redo. All right, so that is not very attractive. And part of this is, again, let's see, the legend is taking up a lot of real estate, and we've got a lot of stuff in here that's not doing much. Let's go ahead and for now, let's hide the legend. So I'll do show.legend equals false. We'll probably bring it back before we're all said and done. And so there again, we can see that really there's only 4 phyla where anything's happening, right? The Actino, the Pseudomo, the Bacillota, and the Bacteroidota. Like everything else is really low. And again, if you think about like the way they wrote about this section, they didn't talk about the Diphtheria, the spirochetes, the Campylobacterota, really. So let's focus on those 4 phyla where the most is going on, okay? And so let's see, where are those? I'm gonna go ahead and grab these phyla. And we'll come in here. And again, what I want are the Bacteroidota, the Bacillota, the Pseudomonads, and then these. Okay. And so here, I think I will do my filter phylum %in %, and then we'll give it as a vector. Right. And so I guess we can't see much there, but if I did a count on phylum, should only have 4 phyla here. Bing, right? And so now if I pipe this into ggplot, there we go. We now have our 4 phyla. And the constraint I'm adding to myself is that I want this to look good in the same space as it was in the original plot, right? So like, this is how much real estate the plot took up in the overall figure. And so I want to use like the same space, okay? So we've got a little bit of work to do to make this maybe look a little bit better, a little more compelling. I'm gonna start, because I haven't finished the geomes, is I need to add the line to my data. And what I'd like to do is, let's try jittering the data. So let's do, I guess I can do that within geome point, right? I can do position equals position jitter. And I can do seed equals 1976, 06, 20. Get that. And so then that's really wide, right? Like we're starting to bleed over different time points. And so let's do width equals 0.2. Is that enough? Maybe 0.5. All right, maybe that's too far. Let's do 0.4 and I'll call that good. And maybe we'll revisit this later. Okay, so there we go. We've got our jittered points. And what we'd like to include then is a line to show the average of these, okay? And so to do that, I'm gonna add a stat summary. And we'll do geome equals line. And we'll then do fun. And I think I want fun, yep, equals mean. And voila, we now have our line plots, right? We also have that legend, which is kind of in the way. So for now, let's go ahead and do show.legend equals false. Like so. And so what's actually very interesting to me is that the Pseudomonadota really doesn't look all that different, right? And again, I'm just gonna say, let's look at ours because their data here is wrong. At least going to the spreadsheet that they provided with the paper, right? And so, yeah, maybe the orange, which I think is the with penicillin, is a little bit higher than the green for these other time points, but again, it's pretty hard to see a difference there. So let's make this look nice, right? So the first thing I'm gonna do is let's do relative abundance on the y-axis. And so I'm gonna go ahead and let's see, let's multiply a value by 100 here. Okay, and so maybe we could go, I mean, that's all but up to 100. So let's take it up to 100. And so again, we'll do like scale y continuous, limits equals c 0 to 100, right? And I'm going to go ahead and get rid of the expansion below and above. And so, I mean, now that I just did this, maybe I should instead do chord Cartesian, and we'll do ylim equals that, and we'll do expand equals false, clip equals off. Okay. And our x-axis then starts at 2, but maybe we want it to start like at 1, and it goes to 12, so maybe we want it to go to 13. So let's do xlim 1 to 13, like so, right? And everything is like big text, which is detracting from the data, right? Let's go ahead and, while we're thinking about the x-axis, let's go ahead and get those to be on the weeks that they are. And so to do that, we can come in and we can do scale x continuous. We'll do breaks equals seek 2 to 12 by 2. Gets us that. And all right. Let's work on the titles of the axes, the labels of the axes. So we'll do labs x. I'm going to say age and then weeks, right? And so one of the things I didn't like is that they have the unit in the text of the x-axis instead of doing like age week. And also they did WK, like y. You can do weeks, right? And then y, we can do relative abundance at phylum level. I think the at phylum level is probably unnecessary just because, I don't know, I feel like maybe people know that these are the phyla, but maybe not. So let's go ahead and shrink all of the text considerably, right? And I'm going to do theme classic, like so. And I think an argument that I can give to theme classic is like base size. Let's do like 8. And so that shrinks that down. What if we do like 7? Remember, like we ultimately used like 7 on the x-axis before. So that's not horrible, right? Let's go ahead and get rid of the background of these strips to get rid of the rectangle around the labels. We'll do theme strip.background element blank. Got that. And maybe we would like to have the x-axis line on these upper panels, right? So to do that, that's going to be in facet wrap. And I think it is axes. It's so rare that I do this that I've forgotten. So instead of fumbling through this, so it's got axes equals margins. And so let's come down here. And let's do all x. And so that is including the text there. And I thought I saw an argument in here, axis labels. And maybe we can do axis labels equals margins to only show it on the bottom, like so. So I think that's reasonable. Let's see. One thing I'm thinking about is what? So I don't like the default colors. The lines, like down here, seem to be on top of the points, right? And so that's an argument in theme, which, of course, I'm forgetting. So it's like, is it like part of axis line? Let's see, where are you? Axis line. Oh, or maybe it's panel something. Panel on top. So let's search for that in here. Option to place the panel, the background grid lines, over the data layers, usually used with a transparent or blank panel background. But I feel like that might be the default. But anyway, let's see. So we'll do panel on top equals false. And I'm starting to have recollections that I've seen this before, and it doesn't work. Rats. Let's see, if we do like panel.background, element blank. Yeah. So I think the problem is that this axis line is getting drawn over the top of the points. So to get rid of that, what I'm going to do is, let me get rid of that panel on top. We'll do axis.line.x equals element blank. So that got rid of that. And what I'm going to do instead is I'm going to come back up, and before geom point, I'm going to do geom hline. And I'm like remembering that I've had this problem before. And so we'll do y-intercept equals 0. And it's unhappy with me because I probably put a comma instead of a plus. And there we go. Now that line, as you can hopefully see, is behind the points. It just meant that I basically had to draw my own axis. I feel like the default axis thicknesses are too thick. So I think I can also do that in Theme Classic, where base line size, let's say like 0.2, which thins it down pretty nicely, I think. So what do you think? Let's go ahead and change the color of everything. And I would probably like the line through my data to be thicker and to stand out more. So let's go ahead and in stat summary, we can do like line width equals 0.5. My fingers wanted 0.4. So I think that looks pretty decent. Let's go ahead and change the color. And so we'll do a scale color manual. And the problem is I've got these ridiculously long names for the treatments. So I'm going to copy and paste these in, and we'll do values, and we'll paste that in, and then that. So then this is width, right? So just to make sure it all works, I'm going to do red and blue. Okay, so that worked, right? But I don't want red and blue. So let's see without. I feel like that should be gray, right? And that maybe well, let's do Dodger Blue because it's been a while since I used Dodger Blue. And so I can think of like with the antibiotic, right, that we see the blue, but without, which is like the control, we then have the gray color. That seems reasonable, right? You know, I almost feel like this figure now is too wide with thinking about the aspect ratio, but and I don't know, maybe some people would like to have the y-axis line there. So let's go ahead and add that. And I think within axes, I can say both. Nope. So let's see. It says axes must be one of margins, all x, all y, or all, not both. So all. There we go. Right. And so, yeah. I think that's pretty slick. Let me know what you think. Like, does this seem more attractive or not to you? One thing that I feel like is, oh, a legend is missing. Let's add the legend. Okay. So let's see. I don't feel like, I don't know. Let's add both legends back in. Make this true. Make that true. So that puts that over here. And I'd like for this to be in here. And I think what we can do in scale color manual is be like name equals null to get rid of that. And then let's go ahead and put that into the upper right corner here. So to do that, we can do legend.position equals inside. And then we need to do legend.position inside, and then we give it an X and Y position relative to the overall thing. So if we do like 0.8 and 0.8, that's gonna be like in the upper right corner, and I feel like we can then kind of adjust accordingly. Right, so that's up there. I feel like these labels are really long, and I don't like that so much. So let's I mean, maybe what we end up doing is changing to be like, well, maybe we could do low dose penicillin, or I'll capitalize it, low dose penicillin. And so without, I'll say no, yes. Right. And so that's all like big and spaced. I don't know that we need the line. I'm going to go ahead and remove the line from the stat summary. I'll do false. And then our legend key size unit, let's do 6 PT. So that shrinks that down nicely. And then our title, we can also shrink legend title equals element text, size equals 6. Okay. And then again, we have that margin around the title. So let's do margin equals margin, B equals 2, like so. And I wonder if we can right justify this. So like hjust equals 1, kind of like that. I feel like low dose penicillin should maybe be 2 lines. like that. I don't know why I don't like it. I don't like it. So that's okay. So let's maybe put it in the upper right corner there a little bit more. So we could do like 0.9 and 0.9. It's actually centering the legend at these coordinates. So we can maybe move it over and down a smidge. So that'd be like 0.95, 0.85. Something like that. Yeah, I don't know. Like the legend, I'm not really sure. Do we really need to say low dose? Good point. Maybe not, right? Because there isn't a high dose penicillin treatment either, right? Something like that. I feel like I'm misspelling penicillin, but what do I know? If we were, look, one of the risks of putting the legend inside the box, inside the panel, is that we might get confused, or a viewer might get confused if these are data points or not. And so what you could do would be to add legend box equals element rect color equals black. And legend, I think it's actually legend background. I'm sorry. Background. And so that then puts that border around it. And we could make it thinner. It could be like line width 0.2, something like that. Yeah, I'm not liking that. I'll remove that. I think it's offset enough from the data that there's no concern that these points are like real points. Okay. And yeah, so there's probably little things that I would do to tweak this further, but on the whole, I think it's pretty cool. One thing that like I would have to think more about is how to indicate which of these are gram positive or gram negative, right? If I were a better microbiologist, I would remember what color the things stain when they're gram positive or gram negative, and maybe I'd make the titles those colors or something like that, right? But like I said, I'm going to leave this here for now. And I think, again, if you compare, let's see, this is mine and this is theirs. Or this is, both of these are mine, right? And so, again, this is, aside from making the plots, like this is like the question, right? Like is, which visualization is more effective? And again, like the argument was that they saw a decline in the amount of gram positives on penicillin and an increase in the gram negatives off without penicillin, right? And, you know, I think that is not the case for the actinomycetota, but it is for the bacillota, right? I think when people think about gram positives, I think they typically think of these are Firmicutes, right? And in terms of like gram negatives, you kind of see it. Well, no, you don't really see it at all. I don't see it with the Pseudomonadota, but you do see it with the Bacteroidota, right? Where it's at a higher level than everything else. And I'm actually very surprised by this other result that we saw by recreating the plot that one of you all, I'm sorry, I forget who it was, picked out, was that this 2-week first rep does not match what they had in their data in the spreadsheet that they posted, right? So it might be the spreadsheet was wrong. Who knows, right? But again, I think this is another benefit of doing this type of work, of recreating other people's data visualizations, is that you begin to notice like, well, how did they get what they had? And, I don't want to be the policeman saying like, oh, they screwed up, like retraction. Like, no, I don't want to do that. But it helps to maybe see, what kind of data do they have? How messy were the data? And maybe what steps would one need to go through to recreate the thing, right? But, I'm not sold that the antibiotic had much of an impact on the pseudomonads. Yes, it did on the bacillota, and yes, it did on the bacteroidota, right? And so I think that's kind of cool. I think my version is a lot simpler, and people might find that actually off-putting. They might think, there's not much there to see. But again, it's much clearer to see, right? Like, I don't know that I see the same relationships necessarily looking at things the way that they had it, right? You know what? Oh, right. Yeah. Yes. That this is the bacillota. Yeah. I mean, I can kind of see some of this, but I don't know. Like, I don't think this actinomycete I could not see from this stacked bar plot. Like, I want to think that a lot of these rectangles are shorter with low dose penicillin than they are over here. But it's not until I put them on the same plot right next to each other that I can really see there's no difference here, right? And again, the other benefit of doing it this way is that instead of having separate columns for the different replicates, I have the data right on top of each other, and I'm drawing the average line through all the data. So I don't know. Again, I think it's compelling. I think it does a better job of showing what the authors wanted me to see in the first place. All right. Well, that's all I've got for today. Sorry for going long. Sorry for being a bit tongue-twisted and finger-tied at the beginning of doing all this. I really enjoyed working on this. I really enjoyed this hack to make the headings for the legend. Again, think of that as two separate legends. Something I will leave for you to do as homework is this other category. Might not actually be gram-positive or gram-negative. It might be a mixture of things, right? Like, I think you could go look and see what the populations are that we put in there, but, go and look and see what you find. And then, think about making a other category and what might that look like to maybe separate that off on its own. Maybe you don't even have a section heading for that, right? You just have other down further than everything else. I'll leave that for you. And if you want, you can check my code because I will go ahead and add that so you can see how I would do it. So do the practice yourself and then come and see how I did it because we're just out of time for today. All right. Well, thanks everyone. Keep practicing with this and I will see